Hello guys and welcome to a new video. We're doing today the last missing case for the Microsoft Excel World Championship 2025 finals. And yeah, by our beloved evil case author Harry Gross, called Malice in Wonderland, with adaptation with adaptation from a movie. And yeah, without further ado, let's jump right into it. So here this is time difference, and since we want to have it in minutes, we have to multiply to get it to the minute format. Here I assume these are special characters with a length longer than 1, and since I don't have compatibility mode as of now, I have to split it with a lambda that is regex based, and then scan 72. Use this as an array, lambda AB. We have to actually round up it every time. If B equals a glass of milk, then A divided by 5, otherwise A times 2. Round it up every time. And yeah, this is matching the sequence here, and we're then using xmatch1 to get to our answers. So now, the next one is quite hard. It is basic from an instruction point, but not from an Excel point. So actually, what we know, all those answers here are unique, and those answers here are not unique, so to say. And what I'm first doing is unmerging this here, and then I'm splitting with our regular text split function. Okay, actually make this a number. Now count most of value. And then we can actually say, okay, 21 is not able because there are multiple answers for this, but 14 and 16, so here and here are actually unique. And then I do the following. I copy this in here, and my text split is then based on this sequence. And I delete this sequence for every part we took away. And now what I'm now doing is doing an XLOOKUP for the splitted numbers. In my count array, and drag this down. We don't need it for this. And now I'm using conditional formatting to highlight where I can enter something. So here I can then immediately say, okay, 18 is possible, the only possible answer. Then delete it. Here it's not 9. 9 is not possible. That was an issue because I deleted it here above. Was this actually intelligent what I did? No, it wasn't. Okay, revert back, Julian, revert back. 21. Yes, because this is then larger. But what we are doing is we are filtering on this here if the number hasn't appeared before. So not is number x match the number in our answers. And we're then using our count or doing our count stuff based on the filter array, where we can see, oh, has it been used before? Okay, it's changing a lot. I should actually make those references absolute. Okay. 21, 6, 11. 6, 11, 21, yes. So, and now I revert back to this example text, and here you might want to start at the end. And what my thought is, okay, basically what we should do here is use those entries that are often and between those 4 and use them here. So here 11, 13 for those, and 11 for the last one. And we can then delete this here, and we now see, okay, those are not possible anymore. Therefore, this has to be 19. And from there on, we also see, oh, here only 17 is possible, the last possible answer. Here we see only 8 is possible. Here we see only 4 is possible. And we go then from number to number. Here we see 12 is the last possible answer. Above it's 2, so delete this there. Here it has to be 6. That is the only possible answer. Here it's 5. Above it's 15. Below it's 7. And now not that many left. Here it's 10. Here it's 3. And the last one is 20. And we solved this basically. Okay, here easy mode. Actually kind of easy. So what I'm doing is using my extract by type, and type in this case is uppercase letters. I then split those uppercase letters into text, use code to get the Unicode number, and I know that the Unicode number of A is 64, therefore I'm subtracting 64, multiply this with 2 and make the sum. And basically doing the same for the small letters, except here the extraction mode, as you can see here, is 4. And not minus, but plus, but I also have to change this here to 1, and I don't know the Unicode for a small a, so code small a, it's 97, so extract 96, and we get our answer. Actually easy if you have some of those lambdas, but otherwise split it, use exact and upper and lower and stuff. That's also doable, just a little bit less convenient. And now we have here a beautiful picture with some value numbers in there. And what I'm first doing is flat this map. I get then here the values and the cells. And now I'm splitting those numbers in RGB values, since these are the RGB numbers. Okay, this is calculating, quite long, but here I have then the RGB values, and I then use text split this, subtract the whole array of splitted RGB values. Yes, this will spill, but does not matter. Then I use ABS to get the absolute values by row sum. Will still spill, I think. Yes. And then min match, min lookup, sorry. It's basically XLOOKUP and min combined. And my return array, first absolute, and my return array will be then those addresses here. And I get to the same address. So basically a little bit of, this has not calculated, a little bit of array subtraction and by row XLOOKUP, nothing too special. And it's all right. Level 6. Level 6, I did a data table. This might break. Oh no, it's not breaking. Oh, interesting. I thought it is using chapter, but in this case it's using example 6 as a reference. Now, these are our rules. He's always starting in the J hard cell, which is cell M16. This is then our start cell. And now split text into letters array. Yeah, no special characters. Cell reference based on reference and arrow array. Cell reference, this is the arrow, this is the cell we're ending at, and it's not calculating because I can also do row or unique to call, because it's not using those characters, but I can simply swap those characters out in my lambda. No column movement, row minus, column -1, no row movement, column 1, no row movement, no column movement, row 1. And here there is special arrow list. Left right is actually the column movement, and up down is the row movement. And we're ending in cell M15. Now these rules we follow. And here, if he moves up to the top row, on the top row, so actually if he goes above here, he's starting here below, and reverse, and the same for the column. So actually, if he's ending in row 15, he's actually reverting to row 19. And therefore RC row number from cell reference and column number from cell reference. And now our star C star for corrected version. If this is 15, then 19. Otherwise, if this is 20, then 16. No. Yes, I know. Otherwise, use the cell given. Should work, yes. So here, if he's then in, here we go, in 20, he's actually in 16. If he's in 15, he's in 19. And for the columns, we have here 14, yes. So equals if he is in 15, then he's actually in 2. If he is in 1, then he is in 14, otherwise use the column given. And then our corrected address is then address of row and column absolute number. And then we use here the cell reference based on this here and do the whole stuff again. Yeah, drag this to the side once and drag this to the side a little bit further, because I do not know exactly how many errors there are, but it seems that there are different number of errors, but I'm not 100% sure. Let's check. Oh, they're always 30. Okay, so I do not have to worry about that. Okay, this is not calculating because I haven't tricked this formula, but then I can basically delete everything from there. Okay, still an error. Okay, here we go. This is calculating G19. I'm using here index, so I don't have any circular or any volatile function in here as far as I know. And then row number is given here, column number is given here. Yes, matching the example, 91, 110, P1, P4. Let's hope that this will not calculate indefinitely. It's basically not that advanced in terms of calculation to do, but yeah, let's see. Okay, longer than expected, but seems to be fine. Yes, everything fine. Now, level 7. I will also data table this. So, 2 row arrow list diagonal second. Hello. And then I only need, yeah, this is when you don't copy the whole array. It's a little bit annoying. I don't need those errors. And now we're here in a maze, which is actually not a maze. And we're standing at different positions. And we want to know, if we look at those line of sight stuff, which card we can see. And therefore I'm using cellref based on reference and error array, not using intermediate steps. Start cell reference is given here. Error array is this, and sequence I use here. 20 should be enough. Sheet name is given here. And indirect. Yeah, this is actually and indirect. And I'm then getting here, this is volatile, and I'm then getting here those numbers. And what I'm now doing is tick x match 1. Calculate, yes, and then to call and filter if this is larger than 1. And I'm getting here my card as a result. So I actually have to watch because these are a lot of enters. I assumed only 30, but they're a lot. B1, B4. This might calculate a while. I'm only turning this off because the sound of the rotor might be annoying in the video. Therefore, I'm turning it off and on so you're not distracted by it. But sometimes I need this because the calculation is kind of intense, especially with the video software running in parallel on a second screen. So yeah, but we should be there hopefully soon. So what we're basically doing here is doing all 4 line of sights and then filtering where the first 1 is appearing, because 1 is the number of the wall. Here until the first 1 is appearing, then taking all in the single column and then filtering for everything that is larger than 1, because we have otherwise 0 for spaces or for blank cells, 1 for the wall appearing, and something that is larger as than 1 for our cards. And we're there by filtering our cards out. And somewhere in the instruction it was stated that only only the cards are single cards, so there are not multiple cards possible. And also there was stated that there's 1 where there's no card. This is an error and therefore there has to be 0, and we then get also the remaining points. Actually, let's do the epilogue. I should write far here. I hope the French pronunciation was right. So some of the red RGB elements, and we actually have those RGB elements here and here. If you reapply the RGB values, then you can see the cat's nose. I currently don't have a macro to apply based on RGB code, but what we can do is the following: text before of this plus text before text after all of this plus text after, but now the second instance, and we therefore get a sum of all those values. And if I then make it a little bit smaller, not that small, you can, and scroll out, you can basically see here some sort of anomaly. And what we're thereby seeing is not that great, but a little bit, are 2 cat ears, somehow cat eyes, and a cat nose. And this cat nose is in cell 090, which is the right answer. If Alice drinks 100 glasses of wine in a row and starting from size 72, how many glasses of milk will she need to drink? Reduce 72 sequence 100 lambda a b a multiplied with 2 a multiplied with 2, and we get there a large number, and then scan this as an initial value sequence, I don't know, 50 or something, lambda a b a divided by 5, and no rounding this time, 50 not 5. Now let's see where the first smaller than 1 is appearing. It is after 36 cells, which is our answer 2. Now we're coming to the evil bonus questions, and they're super evil. First, the first one. Assuming for chapter 6, the king is always starting at the cell and moves 30 uniformly random directions. I googled it. Uniformly random means like real random directions before accusing someone. Which hard card is least likely to be picked? And I'm not able to do this mathematically, but I'm able to brute force this. And that is what I will be doing. Bonus 4. And here, instead of this, I will use index rand array 30 columns 1 1 4 1 and get there a random index. And now actually, since there are kind of a lot of cells here, or kind of, I think they're like 52 cells, I actually have to do this quite often. So in my case, I will simulate it low 4-digit figure. So let's try with 1250. And since this will calculate a long time, I will be right back when this is calculated. But I don't have the mental ability to do this mathematically. And yeah, this would actually not be an approach feasible for a final or something like that. But yeah, I'm not in the UK final. I hope the German case will be easier. Okay, so it has calculated, and let's do the following. To call off this here, and then slow in calculation, and then count if s for this range, and equals sort after the second, and here we see 7 hard has the least amount, in this case 0, of appearances, and it is the answer. Now the last one, we have to go to chapter 3, and actually, yeah, post this here. This stuff here has to be deleted. Okay, so here this is fixed as 9, and those here are not of interest. But we want now to know how many possible answer combinations, kind of distinct possible answers combinations we have. And therefore we do the following. I'm doing the following. I'm doing a text split of this after the comma and combine it with, in this case, the 9. Yes. Hello. This is not calculating properly. And now we see we have 3 distinct combinations. And we now combine this for all other combinations, or also for the combinations here below. But actually, this might not work. Yeah, this has not worked because we have to split by rows. And then we can use to call to row to make it a single column. And now if we would do the same for this row here, you would see that you actually have here an error, because here you combine 9 with 9. And we therefore need to have here a filter function, so to say. So we name this t. And then we do the following: map t lambda a text split text split a row delimiter is backslash and here let s rows of s equals rows of unique of s. And here you see true for everything, and then we filter t based on this array. And here you see this would be, the next would be then 9 times 3, so 27. But as you see here, we only have 18 because we do not count the doubles. And then we can do the following: we can reduce this. Initial value is 8. The array is given here, not the whole lambda a b. And now let's be careful. This is a, this is b. No, the other way around. No, b is fine. And we get there a long result with a lot of columns, and then we use columns. Calculating a long time. No, this is not right. Why is this not right? Because I've deleted the 9 here. Now we get an answer. And yeah, well, this is actually the answer we have searched for. So a little bit over half an hour, but especially the calculation time on bonus 4 was brutal. But anyways, enjoyable case, not as hard as expected. So actually, if you have seen my last video, might be Harry Watson be the new evil Harry, but please, Harry, don't take this as an inspiration to make even harder cases. Thank you for your attention. See you next time. Bye.